Good afternoon, everyone. So, we'll be going through our data mining project in this video, and our data set is a collection of suicide numbers since 1985 to 2016. Now, this data set has numbers for each country, for each country within each year, and the different generations. So, like baby boomer, millennials, and age groups. So I'm going to show a quick overview of the data. First, here we're importing it. So importing the data here. Just run that to ensure. This line right here is trying to prevent scientific notation from happening when we output numerical data. It works on some numbers, doesn't work on all numbers. Here we are removing spaces, full stops, special characters from any column names, and these right here, these are our columns. Now I'm going to just print out a couple records from the data set just to show what it like. So you have the country, you have the year, you have the sex, gender of the person, you have their age group, 15 to 24 to 35 to 54. You have the suicide number for that country, for that age group within that year. Then you have the population, right? And then you have suicide numbers per 100,000 person within that population. And we have the GDP for the year, and we have the GDP per capita along with the generation. So generation is generation X, silent generation, baby boomers, millennials. Now the HDI for a year, we don't know what that means. However, it's NA, not associated. So that's that. Now first we'll start off by visualizing the suicide totals amongst each group to have a better understanding of how common suicide is amongst the different age groups. Now we're using this package, the SQLDF package, to perform basic queries on the dataset, as if we were querying an actual database. So here we're selecting the age, the summing the suicide numbers, and then we're grouping by age, and here we're plotting. So this is the result, and it's color coded. So for age 15, for age 5 to 14, we have a total of 52,264 suicide across the entire data set. And as you can see, the age group of 35 to 54 has the highest number of suicides, 2,452,151. That's the total number of suicides in the 35 to 54 year group across the entire data set. Now we had some questions that I wanted to answer based on the data set, and one question was, what is the average suicide rate amongst different generations per country? Once again, we use our SQLDF package to do the manipulation, do the querying of the data. So we select the generation, the country, and then we divided 1000 by the population divided by the number of suicide. That's the calculation that we use to determine the average, and then we group by generation. And Here we're looking at the first 500 records, and here you can see boomers in Albania. They generally see 3 suicides per 100,000 persons within the population. And for boomers in Antigua and Barbuda, the result is showing that they don't usually have any suicides per 100,000 persons. And if we scroll down some more and look at, say, Generation X at Antigua and Barbuda, interestingly, we are seeing the same thing, not associated. So we're not sure if that's something to do with our query or if it's an actual pattern that's developing there. Generation X for Belarus is 18 persons committing suicide per 100,000 persons in the population. And if you scroll down more, my apologies for that. If you scroll down more and you look at, say, the millennials in, Estonia, we have 4 suicides per 100,000 persons in the population. So that's that. So our next thing is, what is the number of suicide per year across all countries? And this one was pretty straightforward in getting what we want. All we did was we select the country, the year, we sum all the suicide numbers, and then we group by the country, then the year. So Albania in 1987 saw 73 suicide rates. Now, by the time we reach 2010, the suicide rate had been 96, but somewhere in the middle, they've also experienced high number of suicide. Like in 1997, 170 persons committed suicide. And here, for countries like Argentina, in 2015, they had 3,073 suicide. And as you can see, Argentina have pretty high numbers across different years. So in 1987, they had 2,286 suicide totals. And we're looking at some other countries here. Aruba in 2004 had 8. So here we are showing the number of suicide per country across every single year. Now we want to see if there's want to recognize like a pattern, or to see how the suicide numbers has changed across each year since 1985. So we decided to visualize that. So I'm going to visualize suicide numbers for each year. So we query the data, got the data. This is the data that was returned, and here's where we are plotting it. So we decided to use the point type of graph to show the data. So you can see that in 1985 over here, it was right there, but as time progressed, suicide numbers went up, had a dip at once, but it steadily remained high until around mid 2000s it started to come down, and then it saw an increase again in like 2009, 2010, and it has steadily been declining ever since. So we can use that right there to see the pretty much the pattern or the trend with suicide over the years, whether or not we have been experiencing an increase or a decrease. And this will definitely show that in the past 10 years we have certainly seen a decline in number of suicide. However, even though it's a decline, it is really high compared to what it was like, say, 20 years prior to that, say in the 80s or the early 90s. So next we went and said, let's visualize the age and suicide. As you see, the suicide number for each age group over the years, so from 1985 up to 2016. What we did, because this is a large data set, so we randomly selected 1000 records, and then we visualize that. So to do that, we bin the data, which is basically creating the categories, and we use age to create the categories. So categories are 15 to 24, 25 to 35, 35 to 50, 55 to 74, and 74 plus. Now these are the totals for each group after the binning of the 1000 random data, and here we are visualizing it now. Let me just bring that down. So here we're visualizing it now. As you can see, over here 15 to 24-year-olds from our random data selection of 1000, they have at around 160, at around 155, somewhere around there, the total number of suicides. And 35 to 54 have a higher number, close to near 200. 15 to 5 to 14 has a little over 100 suicides from that randomly selected 1000 records. So this can be used to determine like which age group is responsible for more suicide for every 1000 persons overall. Another question we had was which country has the highest suicide rate, and we did a query. So we did the query here, and the results show that Aruba experienced the highest suicide rates per 100,000 person. Now, the next thing we wanted to answer was, can we determine the chances or the likelihood of an individual committing suicide based on their sex, the current GDP per capita in their country, and the generation, the suicide rate per 100,000 person in their country. So we decided to use a regression algorithm to figure this out. So we plucked the data that we needed: sex, GDP, generation, suicide, and we then went ahead and grouped this data by sex and generation. This is the result after grouping it. We then perform our regression algorithm on it here. So here we are using suicides per 100,000 in the population as the dependent variable. Reason being is that if we've supplied certain information to the algorithm and we get back a particular value, we could say that okay, then persons with this sex and this GDP and this generation, there's a higher chance they're more likely to commit this number of suicide per 100,000 person within that population. So you can see how many, say, GI generation is possible or is likely to commit more suicide, which is basically what we're trying to say here: the chance of an individual committing suicide. So the generation plays a key role in our algorithm here. So now we're doing a summary of our regression to see how well each of our independent variables really influence the dependent variable or influence the outcome of what we are trying to accomplish. Okay, we're printing out the coefficient for each variable, and then we are plotting it to see the results here. Alright, so the next thing I wanted to find out is, can you tell me the age group of a suicide victim based on the GDP, the population, GDP per capita, the population, the suicide number per 100,000. So what we're trying to do here is, let's say we're in a country and someone committed, we heard news that someone committed suicide. We could say, okay, what's the current GDP per capita in this country? What's their population? And what's the usual number of suicides per 100,000 person? And from that we can say, alright, it's very likely that this person is from this particular age group. So just a little note of other things we can find out. We can know things like, in large countries with good economy, which age group falls to suicide. We can see how does the rise or fall in population influence groups more susceptible to suicide. We can see in countries with a certain suicide rate and population, which groups commit the most suicide. So here we are pulling the data that we need, just the columns that we will be using to find this out. Now we are creating our X and Y data. So these are X data, and Y is basically what we are trying to find out. So we're setting the data to be a random here. Random is setting 500, and then we're splitting the size. So we do 70 for testing, and the remaining 30 will be used for 70 for training, and the remaining 30 will be used for testing. Now here we're setting up our training data and our test data, and we perform the test. And next we're going to build our classifier. So here we build out our classifier, and then we plot our classifier. Now this is showing that as the tree increases we have less errors. As the size of the tree increases we have less errors. Smaller size of the tree we have higher level of errors. And now we are plotting the tree. So if I zoom in a bit, you can see the results of the tree being plotted. And on the tree, GDP per capita was not shown or was not used in the actual decision tree. We're not certain as to why. Now we are going to plot the same tree using a different visualization of the decision tree, something more graphical, more interesting. So let's say the suicide number per 100,000 is 1.53. Can follow the decision tree and see what age group the person is more likely to be from if a new suicide has been committed.
Hello, Mr. Gordon. My name is Kadim Nelson. For my part, I did the k-means clustering for the project. To do this, I created my own data frame called suicide AMT, suicide amount, and filled it with data using this SQL statement here. Contained within this data frame is the sum of the entire population separated by country, and the same for the suicide numbers. This includes all the population and suicide numbers across all age groups, all time frames, all genders, all of that. So it's just the total suicides versus the total population. And down here is a scatter plot showing that representation. Now I need to decide how many clusters are in the how many centers I'm going to use for the cluster, or how many clusters there will be. And to do that, I didn't want to just choose a random number. I chose to use NB cluster. I chose to use these packages, and specifically the function NB cluster comes with it. And for that, I used this line, as you can see here. And the minimum number of clusters will be 2, the maximum number of clusters will be 15. Right? Now, using this algorithm, it showed me that 6 of the indices propose that I use 2 clusters and 6 propose that I use 3. But looking at the graph, I can see 2 clusters more than I can see 3. And it also said down here, according to the majority rule, the best number of clusters is 2. So I decided to go with 2. So then I come down here, I'm plotting the k-means clusters. Plot the centers, show them in a table, show how the data is distributed between the two clusters, and show how much data is in each cluster in this graph here. These are essentially showing the same thing, but this is in a easier to read format than counting all those 1s and 2s. Now down here is the actual scatter plot, and if you notice, in cluster 1 down to the lower left, the plots are, the points are closer together. What that says to me is that the population can serve as a good determining factor in the rate of suicides, which is to say, if you have a lower population, you're gonna generally have lower suicides, right? Because there are some slight deviations, but for the most part, once you have a higher population, you're gonna have higher suicide rates to varying degrees. But if you look at cluster 2 over here, they are all over the place. They are far from the center. They are all in their own space. So what that says to me is that as the population increases over here, they're going to have a lot more factors that affect it than just the population. A lot more factors that affect the suicide rate than just the population. And that's the difference I see between these two groups here. And that is my part.